So I'm not going to have another exams. It's just homework assignments. Okay. So the last few sections, just do the homework and you'll be good. And of course, we'll have the final, whatever date I posted on the syllabus. And I'll double check and email you the date just in case. But it's coming. I guess the end is near. The final will be based on all the exams that we've done. So I'll just go over all the old tests. I was thinking of posting videos of every exam that we've done, all the solutions. So I'll probably do that, and then I think Monday after we get back is the last day, right? I think. So that day we can talk about the final. All right. We'll go from there. If it's not the last day, then we'll review some more. I gotta check. All right, so on the homework, the entire section is about exponential functions. And the first question is a word problem. It says that force A is represented by a function called a of t equal to 114 times 1.015 to the t. So this function models the growth of some trees in some forest. Okay. Forest B is represented by a function called b of t equal to 94 times 1.025. All right, so just real quick, some note. I wrote that out weird. Y equal to, so here's y. Doesn't matter. Y naught times some base b to the t, or y equal to y naught e to the, or y sub 0 if you prefer, e to the kt. Y sub 0 is the initial amount. B and K are the growth rates. Growth rates. All right. T will be in, most of the time it's going to be in years. But in this example, time in years. But it will be time at all. It will always be time. It may not always be years for these types of questions. All right. So first question. Which forest has a faster growth rate? Okay. So just look at the number, right? B has a faster rate. So forest B has a faster growth rate. of 1.025. I don't know if I should need to be more clear, but I'm talking about the rate of trees growing, not when I say growth rate of a forest. T is in years, and A or B, the outputs are going to be the total number of trees. Okay. Which forest initially has more trees? Well, the initial for A is 114. So you can just write this number down. That'll be your initial, or you can plug in 0, which is time 0, the beginning. So that's just your output. So A of 0, which is equal to 114 times 1.015 to the 0 would be this amount. B of 0 would be 94 times 1.025 to the 0, which is 94. A has more initial trees. Although we should see over time, B will have more because it has a faster growth rate. I don't know how long it's going to take, but eventually it'll overtake A. C, how many more trees? Does A have than B? That's not too bad, right? I think it's 20. Final question. Or number 1, which forest will have more trees in 30 years? So which forest will have more trees in 30 years? So just plug in 30 into your function and you'll be good. So A of 30 is going to be 114 times 1.015 to the 30. B of 30 will be 94 times 1.025 to the 30. At that point, you just gotta use a calculator. Let's see. So 114 times 1.015 to the 30. 94 times 1.025 to the 30. So 178.19, 197.17. We should probably round to the nearest tree. I think that's kind of weird, so let's say that the first one is 179 trees. And this is 198 trees. So you can see that in 30 years, B has already surpassed A. And it'll continue to be ahead. Okay. Anyway, so number 1, the main thing you need to know is, can you find the initial amount of whatever they're talking about? Can you plug in numbers and calculate what the future amount will be? And Can you identify the growth rates? That's about it. Any question number one? Yes.
Oh, what's the one?
Yeah, K right here is the growth rate. So the B and the K are both growth rates. T is just the time. Let me write that a little better. I write you another note at the bottom. Note if B, should I phrase it? If B is between 0 and 1, then you have decay. Instead of growth. If K is greater than 0, then, I'm sorry, if it's less than 0, there you go. So if B is between 0 and 1, then you have decay instead of growth. If K is less than 0, then you also have decay. So instead of having something grow, it'll just deteriorate. Usually we use those models for radioactive substances that decay over time. Um, so given an initial amount, it's slowly being used up. Okay. But if K is positive, like this question, or B is bigger than 1, we have growth. See how both of these B's right here are bigger than 1? And they're not a fraction. Less than 1, so growth. If this was below 1, the trees would go to 0. Would just start dying off, I guess. Any question number 1? Okay. Example 2. Consider the function y equal to 3,222 e to the negative 0.85. See how the k is negative. So that means that this is going to start to decay. You're going to start out with this amount, 3,022, whatever. Over time, given an infinite number of time, this will go to 0. Of course, we're not going to deal with infinites, but over time it will shrink. Which is of the form y equal to a times e to the rt. All right. Part A. What is r? Right, so the growth rate is going to be right here, right? So since it's negative, what does that mean? What type of change do we have? we have decay because R is less than 0. So they'll ask you stuff like this. What type of growth rate? Can you identify the initial amount, the rates, and can you plug in numbers? So given a random exponential, can you plug this in? Say 2 to the, I don't know, 2x minus 2, find f of negative 3. So f of negative 3 will be 2 to the 2 times negative 3 minus 2, which is some weirdo number. 2 to the what? Negative 8. As a decimal, it's going to be pretty small. Two to the negative 8. It'll be, what is that? Positive, sorry. 0.0039. No question about 3, right? Just plug in the number, and that's it. Scientific calculator or graphing is all you're going to need. Okay. Let's do another word problem. Let's use this fox question. So the fox population in a certain area has an annual growth rate of 9% per year. In the year 2012, there were 20,330 foxes. All right. So part A, find the function f of t that models the fox population. Okay, so if we assume 2012 was the uh, initial amount, the first year that we started measuring, so the initial amount would be 20,330 foxes. So we could say that the formula we're going to use, right? I think in the book they use A-E-R-T. A is the initial amount. R is the rate. T is time, right? So f of 0 would be the initial amount which is equal to 20,330. But that means that A is equal to 20,330. That makes sense? It's the initial amount, so this A right here should be this. Right? In other words, if I plug in 0, it has to be equal to this. And if I assume that is 0, then that means 2012 is going to be year 0. That's when I started. Part B. So we found A. K was given to us, right? 9%. So 0.09. Sorry, they used R. R, not K. Too many math books use too many different letters. It's all the same, though. It's all the same. So R is 0.09. A is 20,000. Now B will ask you, how many foxes? In 2020. Well, use the formula we just figured out, right? F of t is equal to 20,330 times e to the 0.09 t. I ran out of space. So 2012 is 0. What year is 2020? Right, that's 8 years later. So we can assume that this is year 8. That makes sense? So just plug it in your calculator. Oops. And that's it. Whatever that is. I think I got 41,767 a lot earlier. So the homework's going to ask you to figure out the model by plugging in your initial amount and your rate, and then they'll ask you to for what will happen in the future using that model. Okay. Why 8? So we assume that 2012 was the beginning, year 0, and they wanted to know what happens in 2020. So 8 years later. Of course, most of the time in real life, these equations get more complicated because you have to worry about if you start to incorporate food, predators, parasites, all the things that might kill the fox, you get a more complex equation. It turns into a system because you can't breed infinitely, right? There's always a limiting factor. They'll say, okay, you can't have any more foxes. They like, let's say you hit 40K and they eat all the food, so now there's not enough food for them, so they start to die off. So they have a natural barrier, just like we do, right? I think our population is trying to go down. You've hit a peak. Any question number 4? Okay. I think that might be everything for that section. Yeah, so that's pretty much it. You'll have solving those pieces, initial amounts, growth, plugging the numbers. Then at the very end, you'll have graphs. So be able to graph your logs, or I'm sorry, your exponentials. Are you comfortable graphing them? Like, just do you remember how we did the shifts? the vertical and horizontal. It's the same thing, just do it to the exponential. Okay. Let's move on to something else. Unless you have questions, let me know. Okay. Move on to logarithms. Okay, so let me give you some properties and formulas. This is pretty much the main definition. Given log base b of x equal to y, this can be changed back and forward into b to the y equal to x, comma b greater than 0, comma b not equal to 1. Okay. So the first example is pretty chill. Just transform it from log to exponential. That's it. Using this definition. So rewrite the equation in exponential form. So log base a of 8 equal to g. So change it. So the base a is going to be still the same base for the exponential. It's going to be equal to the argument of the log. All right, so it says here. This base is right there. This argument is equal to. This equal part is the power. So this will be g. That's it. So you just change it using the definition. Now go the other direction. Rewrite the equation in logarithmic form. All right. So 6 to the p equal to a. All right. So the base is 6. So it'll be log base 6 of whatever this is equal to, right? This is the argument. So a equal to the power, p. So I'm just matching these up. That's it. Any questions on 1 and 2? It's okay. All right, let me give you a bunch of log properties just in case they come up. First one, if you plug in the number 1 into any log of any base, it's equal to 0. Number 2, if you plug in something that matches the base, they cancel out and leave you the 1. Number 3, if you plug in a base with a power on it, you're left with the power. It's supposed to be an A. Number 4, If you have a product inside, you can separate them using addition, and vice versa. If you have addition, you can go to a product. Okay. Now, if you have division, you can change it to subtraction. Whatever's on top goes first, whatever is on the bottom goes second. So a to the log a of x equal to x. So if you have the bases matching in the other direction, they will also cancel just like rule 3 does, kind of the reverse. Okay. So if you want to cancel a log, this is how you do it. Number 7, this one's kind of important. If you have an equation with the same basis, a to the x equal a to the y, then you can change that into x equals y. So the cool part of this is you can change an equation and introduce whatever base you want. So I can actually put some bases underneath. Does that make sense? I could choose a 2 to the x equal to 2 to the y, or whatever. Any base. Okay. Log base a of x equal to log base a of y implies that x is equal to y, or vice versa. If I want to introduce any log of my choice here and here on both sides, I can do that and get back here. Okay. A couple more notes here. Log base e of x is equal to ln x. This is called the natural log, in case you forgot. Number 10, if they do not write a base, it's understood to be log base 10, called the common log. So those are the ones on your calculator. On any scientific calculator, they have two dedicated buttons, the ln and the regular log, the common. If you have a fancy calculator, you can choose your bases if you want, but it's unnecessary. But anyway, that's all your formulas are going to need for this section. Okay. You guys cool on this page? All right. So apply those rules to these next few questions. So example 3. Solve the following. Log base 8 of x equal to -8. So in order to solve this, introduce a base that will let you cancel the log. So since there's an 8 here, purposely introduce an 8 as your base on both sides. So these will cancel, getting you to here. X will be equal to 8 to the -8, just some large negative number. I'm sorry, small number, not negative. The homework said you can use your definition instead. You can also use your property to just get there right away. So 5.96 times 10 to the -8. 5.96 times 10 to the -8. So, in case you forgot, that e -8 means 10, scientific notation. Okay. It's just a bunch of zeros in front. So we use property, what is that? 6. So from here to here, we're combining properties 7 and 8. Any questions on number 3? Is that clear? All right. You see, we brought the 8 in and the 8 canceled the log. Okay. Same question. Solve. ln x equal to 8. A lot of 8's today. So ln is base e, so introduce an e on both sides and you can cancel. So e to the ln equal to e to the 8. So these cancel. That gets me to x equal to e to the 8, which is some decimal. I don't know what it is. 2 to the 8. It's like a few hundred something. So this was property 7 again. Sorry, this should have been 7 and 6. Okay. And then after the first few questions are going to be just use a definition. Then they'll ask you to solve some basic equations like this. And then the next few are simplifications. So simplify log of 10,000 squared. So just remember that if they don't write the base, it's assumed to be 10. So that matches the tens, right? So this will be log base 10 to the 10,000 squared. So how many tens is 10,000? Many factors of 10? How many factors? Or powers, I should say. It is 1,000 tens, though, I'm sure. That's true. You agree that this is the same as 10 to the 4th squared. 10 to the 4th, 10 times 10 is 100, times 10 is 1,000, times 10, 10,000. So 10,000 squared is the same as 10 to the fourth squared. And if you have a power to another power, back in middle school, we said you multiply, right? Now we can use property. Three. If they match, you're left with just the power. So they cancel. Any questions on 5?
Why is it loud?
If they don't write the number, it's understood to be 10. It's like square root, they never write 2, but we know they mean root 2. So it's I don't know, laziness, maybe? I don't know. Tradition. Okay. Last one. E to the ln of 2.89. So right away you should see these cancel, right? Ln and E are the same base, so they cancel into 2.89. All the questions after this are just, can you graph them? Or can you move them around, shift them? I'll let you mess with those later. Okay. Let's talk about limits real quick. And then we'll be done with the whole semester. Isn't that cool? Pretty exciting. Let's see here. So those of you that are going to calculus, the first chapter you're going to do is limits. So this section will put you ahead. We talk about it a little bit. What the hell is it? Oh, here it is. It's very visual, so I think once you see it, most people will understand it. Let me share the screen so I can record this part. Okay. So, real quick, this red graph right here is some function f. It's all f of x. See the notation they write limit lim as x approaches 1. This is to asking you, what is the function doing as we approach the x value 1 down here from both sides? From, so I can get a pin out here. Can't. Let me if I zoom out a bit. A second. Oh, there it is. Okay. So as I approach from this side, and I approach from this side, what is the y value approaching? That's what they're asking. So when they say the limit of f as x approaches 1, you would say, well, it's approaching 1, 2, 3, 4. It's approaching 9. Right? So the answer would be 9. So as it's approaching from both directions, what is the y value? That's what this is asking. This notation makes sense? Now, if they write, let's go to the next one. Take this guy out, see if I can zoom in a bit. Maybe this will be better. Okay. You guys see this okay or no? All right, so notice how they have this new notation. What's the function? So f is this entire graph right here. So what is the function doing as x approaches -1? See how it has that minus symbol? So that's asking from the left side, the negative side. So look at the picture. Man. Look at the picture. As we approach from the left side, we're going to the number 1, 2, 3, right? Going to 3. The next one says, what's going on from the right? So I approach -1, which is right here. From the right side, it's also approaching the number 3, the functional value 3. Since these are the same, the left side and right side, you would say that the limit exists at -1, which is also equal to 3. That's all we're doing. Does that make sense? Or no? So this one is 3, also 3. If these are equal from both directions, then you say the limit exists at 3. Okay. So from the left, I'm approaching right here. From the right, I'm approaching that same little hole right there. So the number is 1, 2, 3. So this is 3. So what is the y value that they're approaching from both directions? It's going to be 3. Yes.
So value of 1 is
Yeah, that is talking about the x value. So there's technically a hole there, so I can't plug it in. So the reason we talk about limits is because it's undefined there, but we can kind of see what it's doing as we get closer and closer. So the function is defined at 4. See that how the dot's right there? So it's not defined at 3 though. So if you scroll down, oops. Zoom out again. So the limit exists at -1, but the function will not be equal to that limit. So if they're not the same, you would say it does not exist. Okay. Look, check out this graph here. This one's a better picture. What is the function doing as we approach 1, +1, which is right here, right? From the left side. So from the left side, we are coming up, that just here, this direction. Let me move this. From the right side, we're approaching this direction. So the limit from the left is actually going to be 2, 3, 4, 5, right? From the right, it's going to be 0. So we're talking about what is the functional value, the y value. Since they are not the same, you would say the overall limit does not exist. So we have one-sided limits and double-sided. So if they don't have the symbol, you assume double. If they say negative, it's left. If they say plus, it's right. Yeah, so sometimes because it's kind of broken, so it has 2 different y values. Going this way, we're way up top. From the bottom, we're on the bottom. So it's disconnected there. So the limits are not the same. Therefore, the limit does not exist at 1. Although the function is defined there, right? If you plug in the number 1, you get 3, or I'm sorry, 5. But the limit doesn't exist. Okay, so if you're worried about calculus, just make sure your algebra skill is good and just go over the limit section and you should be ahead. Okay. All right. Any question about limits? Does that idea make sense or no? Is that clear? Because it's very visual. I feel like it's not too bad. So they'll just give you different graphs and you just figure out what's happening on the left side, what's happening on the right side. Just go to that x value. If it's -1, well, you go to -1 and you look at the function at that location. Right. All right. I will stop here.